There's many ways we can try and compress data losslessly, but what we are going to rely on in this lecture is the prefix-free code. So let me first tell you about how data is generally stored in an uncompressed format on a computer. Generally, English text is represented by a sequence of characters, for example, the word dog, and each character is going to be represented by 8 bits. So the letter D will be represented by 0, 1, 1, 0, 0, 1, 0, 0. The letter O would be 0, 1, 1, 0, 1, 1, 1, 1. And so if we have the word dog in a file on our computer, somewhere in binary is represented these 24 characters in a row, typically. Now I'm also showing the result in hexadecimal, not something we've talked about in this class, but be aware that it exists. And if you take 61C, this will be something that's important, just putting it here for those of you who may have seen it before. So one easy way to compress text would be to say, I'm not going to do the normal thing. I am not going to store D as 0, 1, 1, 0, 0, 1, 0, 0. I'm going to pick some shorter sequence. And so in order to do this, what we're going to have to do is decide which bit sequences go with which letters. I'm going to decide I'm not doing the normal thing. I'm going to make 0, 1 D or something. And more generally, this notion of associating bit sequences with letters, you can generalize it to say which code words, that is, sequence of binary digits, go with which symbols. And this more general terminology just captures the fact that it may not be English that we're representing. It could be Chinese characters, musical notes, whatever it may be. And code words is some sequence of bits. Okay? So let's see an example of a set of code words that represent symbols in English. So you may have heard of Morse code before. And here each code word is a sequence of variable numbers of bits. So for example, the letter E is a dot. And the letter Z is a dash, dash, dot, dot. And we also here represent numbers. So the possible symbols are the letters in English and the numbers, and we don't distinguish lowercase and uppercase. And the code words are the dashes and dots that we see. So as a way to see if this makes sense, what I would like you to do now is figure out in Morse code, what is dash, dash, dot, dash, dash, dot. So using this table, try and figure out what that is. Pause the video, and then I'll give you an answer. So it turns out it's a bit of a trick question. There's multiple possible answers. So this could be either meme, or it could be GG. So meme, for example, is dash, dash, dot, dash, dash, dot. Whereas GG is dash, dash, dot, dash, dash, dot. There's no distinction. Okay? So just a few notes here. We can think of dot as a 0 and a dash as a 1. So each of these dashes is a 1 if you want to translate directly. And another thing that is worth noting, which is maybe more interesting, is how is this dealt with in practice? How do you avoid ambiguity in Morse code? Well, you use a pause in between each character. So if I'm doing GG, I would do beep, 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 beep. And that pause, in some sense, you can think of it as a third symbol, like a 2 or something. So that's cheating. And so what we're going to do is try and avoid this problem in an alternate way. Now, before we do that, I do want to note that if we used Morse code as a way to represent our characters, and we somehow are able to deal with this ambiguity issue, indeed here we're using fewer than 8 symbols per, or sorry, 8 bits per symbol, and so we would get ultimately some compression relative to the default encoding. That is, rather than using 8 sequences, or sorry, 8 dashes or dots to represent a D, we're only using 3. Now the problem with that, of course, is that we couldn't use Morse code on a computer because there would be ambiguity between meme and GG. So if we tried to uncompress the data, we wouldn't know when we get this whether or not the original sequence was meme or GG. So the strategy we're going to do is we're going to make our codes what's known as prefix-free. That is, we're going to make sure that it's never the case that any combination of characters exactly resembles another. Now, if we draw out Morse code in a different way, looking at Wikipedia, we see the problem more clearly. So for example, in Morse code, the letter M, shown here, is dash dash M, is right here, whereas the letter G is dash dash dot. So this character G, it is a suffix of the letter M. Or maybe better put, M is a prefix of G. We can see that immediately, right? M is a prefix of G. And in the Morse code tree, the fact that some characters appear above others causes you problems. So if we wanted to fix this, we can build a code which is fundamentally prefix free. And so we'll do that in the next video.